Okay, welcome back again. Tonight we're going to talk about reliability. and Reliability is a much simpler concept really than validity is. Some of you may have heard the two terms really used together quite often. And reliability is really nothing more than getting the same results or similar results each time you perform an assessment. Now, this seems intuitive that if we gave a child a test 2 times that they would do about the same each time they took the test. However, we find that in practice reliability is actually quite a bit harder to achieve. So the concept's simple, the execution is a little bit more difficult. So I just want to go through a few basic definitions of reliability. This is going to be a short segment this week, but that doesn't mean that simply because it's short that it's not significant and important. The first kind of reliability I want to just mention is temporal stability. This is the idea of test-retest reliability. And this is one of the types of reliability that test manufacturers often use to demonstrate the efficacy or the alignment of their own tests. For example, if you were to be giving the KTEA, the Kaufman tests of educational assessment, you would find that the authors gave children the assessment and then waited a period of time and gave children either the same assessment or they gave them another version of that same assessment. If they give them the same assessment at a later point in time, but not so much later that you would expect the child to have gained knowledge, this is called test-retest reliability. Now, as you noted in the slide, this is clearly not a practical approach for teachers, and it's not really a practical approach for many situations. Repeated measurements, for one thing, are likely to change the examinees. Now, I can give you an example of this in a recent project that I've been working on. I've tested preschool children over time, and even though the window of time that we're using to do our tests and retest using the same form of an achievement measure for reading is well outside the limit for the tests. In other words, the limit for the test is 30 days. We're not testing any more frequently than every 90 to 100 days. However, we're finding that, or I'm found in testing these children, that there's clearly practice effects for them, that they recognize items, and maybe even if they knew the correct answer to an item when perhaps they missed it the time before, some of these students, I believe, were queuing into the item format and were going right back to the same prompt or response that they had selected the previous time they had taken the test. So temporal stability is a difficult measure, and it's also one that I think is easily susceptible to corruption, and especially in terms of the learning curve that I just spoke of. Another type, and this is a very common type, it's called form equivalence. And this is where we have 2 different forms of the same test. They're based on the same content, and they're given on one occasion to the same examinees. So what we would find is that essentially we have a very long test, say 100 items, that was given to a norm group. And a norm group, of course, is a group of people that the test manufacturer or the test publisher has selected to try out the test. And we'll give it to that group, and they'll take all 100 items. Now, what we'll actually do then is we'll take 50 items, and we'll turn that into one form of the test, and we'll take the other 50 items, we'll turn it into the second form of the test. And we go through an equating process where we ensure that each of the items is equivalent in difficulty level to each of the items in the second form of the test. Now, this is an imprecise approach to reliability as well, because even though we take our best guess at finding equivalent forms or equivalent items, what we find is that at the individual child level, that the exact item that a child gets is highly significant in predicting whether or not they'll get that item right. For example, if we use an item in an early reading test that is from a book or from a character that a child may have had previous exposure to, they may be more likely to get that item correct than if they had never read that story. Now, it may or may not be indicative of their true understanding of the reading concept, but rather their familiarity with the task or with the characters of the concept. So, equivalent forms is an important format for test reliability, but it's also imperfect because even though our items are similar, they're not precisely identical. So I think it's important for you to be aware that when a test is given in a school, sometimes the MEA will be given and there'll be multiple forms, although the core items are still the same. But in individual achievement testing, for example, with kids with disabilities, they're given tests like the Woodcock-Johnson tests of achievement, and there's a A form and a B form of this test. And I found as a special ed teacher that children perform slightly differently on the A form than they did on the B form. So depending on which form of the test a child takes, we might see slightly different results. Now, overall, across many individuals, these differences are non-significant and the forms are equivalent. But it's very important at the individual child level to remember that when we've got multiple forms of a test, that individual kid results can vary significantly more and are much more sensitive to the exact content of particular questions within the test. The third type of reliability that I'm going to talk about is called internal consistency. And this is talking about the coefficient of the test scores obtained from a single test or a survey. So, in other words, to what degree do the items within a test agree with each other? Now, it's often referred to as Cronbach's alpha. There's some other types, which is KR20, which is the Kuder-Richardson formula 20. 20, I don't know where that comes from, to be truthful. Kuder-Richardson are the researchers who developed the formula. And then there's a split half method, which is really what I just spoke about, taking the 100 items, and we could take all of the odd items, and then we could take all of the even items. Now, mathematically, Cronbach's alpha is similar to split halves, and it's as if you had taken all of the possible split halves. So if you can think of 100 items, in all the ways that you could split that into two groups, it stretches out almost to infinity, it would seem. Cronbach's alpha is designed to approximate all of the possible split halves of that data set of those 100 items or 50 items or however many items we might have. Okay, so obviously we've changed venue since I started recording this last night. We are finishing up with this discussion of internal consistency, and internal consistency, again, is really just the degree to which the items within a test agree with themselves. And although that may or may not make a lot of sense to you, depending on what your statistical background is, I'm going to show you a little bit more dynamic look at how this works in just a few moments. But before we do that, I'm going to go on and we're going to look at a few other issues, and then we'll look at that and wrap it up. So I'm going to give you an opportunity to actually try calculating internal consistency, and it is a laborious task to do by hand, but you can have the opportunity to pick up one extra percentage point on your final grade by electing to do this little extra credit assignment. So here it is, and this is the only place that it will appear. In Measured Measures, in Appendix C, there is a piece that explains how to calculate internal consistency. In other words, how to go ahead and calculate Cronbach's alpha. So you're going to, if you want to accept this little extra credit assignment, you're going to come up with at least 20 students, and you're going to have scores for each of them for each question. And so you're going to have 400 cells, 20 students by 20 questions, and you're going to calculate the internal consistency for your test by hand. Now you can check this with the computer, but you have to do all the calculations out by hand if you want to pick up the extra percentage point. Some folks elect to do this, other folks don't figure it's worth their time. But it's an interesting task to undertake because it really gives you a very close look at how the deviation scores are working together to create variance, and that in turn gives you an estimation of your internal consistency. So I think if you want to go ahead and try this, you'll find the materials that you need in Appendix C, and then you'll have to fabricate your own set of child test scores unless you happen to have some. If those of you that are practicing teachers, if you take a recent test that you've given, you'll have to actually go back and look at the original test to see which items children got right or wrong. And typically, this only works with selected response or Boolean outcome kinds of items. In other words, things are right or wrong. They're not partially right or partially wrong. It is possible to do it with items like that, but it's not quite as straightforward. All right, so reliability in practice. Well, we've talked about a few of the different types of reliability, but what we haven't really touched on is why. What is the importance of this? Why should I be concerned about this? We know that reliability is the measure of how consistently a test or an assessment yields the same kinds of results over time or with different items. And we also know that reliability is a necessary but insufficient condition for validity. So we started with validity. Validity really is the most important thing in assessment. In other words, are you measuring what you say you're measuring? You can't be measuring what you say you're measuring if you can't get the same results twice. And this seems logical if you stop and you reflect on it. If I get on a scale and the scale says 5 pounds, and that's away from 0, I am always going to over-report my weight by 5 pounds. So is my measurement consistent? Yes, it is, but it's consistently wrong, so it's invalid. On the other hand, if it measures by 5 pounds under my actual weight, perhaps I'll consider it to be a valid measure. But more importantly, what happens with the scale where one time you get on it and it's 5 pounds over and the next time it's 5 pounds under? Would you consider that scale to be worthwhile or useful to use? Or would you say this is junk and you'd throw it into the garbage can? Most of us would probably take that scale and throw it in the garbage can. So what if the scale was over or under by 1/2 of 1 pound though? So one time you get on the scale and it reads 1/2 pound high, actually 1/2 pound more than you actually weigh, and the next time it reads 1/2 pound less. How many of you would throw the scale away if it was only 1/2 of a pound off each time that you measured? So reliability is a matter of degree as well. We said that validity was a matter of degree, and so is reliability. So some measures we see are highly reliable. For example, if we look at individual achievement testing, where we have many items across many subscales, the final score for that is quite reliable. It's within a very small standard error, and we'll talk about what standard errors are in the next segment when we talk about descriptive statistics and standard scores. But suffice it to say that some tests give very consistent results, where other tests give quite inconsistent results. So why concern yourself with this? Why is this important? Well, in one survey of teacher-made tests, many teacher-designed instruments had internal consistency scores of 50% or less. Okay, so they achieved a Cronbach's alpha 0.50 or less, meaning that half of the test was error. For these individual assessments, we see that half of the students' predicted performance was error variance, as it's called. In other words, random effects. So if half of your score is from unknown factors and half of it is reliable, how then do you make a judgment about student performance? So what impacts reliability? Well, there's a variety of things that have either a positive or a detrimental effect on the reliability of an assessment. One is test length. All of the things being equal, the longer your test, the more reliable it's likely to be. The second thing that reliability depends on, particularly internal consistency, I should say, is variation in scores. If all of your students get a perfect score on your test, your reliability or your Cronbach's alpha will be 0. There's no variation, therefore there can be no reliability. There isn't any sense of consistency other than the consistency is that all students got the same score. but it doesn't calculate in terms of reliability for Cronbach's alpha or internal consistency. Now, there are some folks that will say that all of your students getting a perfect score in your class is actually the desired reliability outcome. And that could be if, in fact, your criterion is some predetermined performance and all of your students have achieved that predetermined performance. Now, that's a whole different ball of wax, but when we're talking about internal consistency, variation in scores is necessary. And it's not just desirable, it's necessary to actually calculate internal consistency. The number of students that you have taking a test, if you have, and this again, all of these things really come back to kind of common logic. If you have 3 people taking a test, it's difficult to know whether your test is going to give you consistent results. If you have 300 people take a test, then you're going to have much more confidence in the pattern of results that you get. And then finally is the varying difficulty in items, so that not all students do the same way on all items. In fact, we see some items are more difficult or less difficult than others. Okay, we're going to jump out of this for a moment, and we're going to take another look at internal consistency, this time with the use of a spreadsheet calculator. I've also provided you with a link to this, and you can download this and use it to verify your work if you decide to do that extra credit assignment. So let's take a look at it. And here we go. So here you'll see a variety of cells that will allow you to do different things. Now, I've prepared some data sets in advance. You can go ahead and play around with this by entering zeros and ones. Now, zeros and ones, 0 stands for the child got it wrong, and 1 stands for the child got it right. So for example, let's say that I were to take a 1-question test, all right, and start plugging in values. So if I plug in a 0 and a 1, whoops, 1, 1, 0, 1, 1, 0, 1, 1. Okay? So Cronbach's alpha, notice, can't calculate. We only get a single item. Okay? If we add a second item, we'll start to get some results. So 0, 0, 1, 1, 0, 1, 1, 1, 0, 0. Okay? Notice that I have a very low Cronbach's alpha. I've only got 2 items, and even though I have some pattern of results, we see that children that got 1 item wrong seem to be more likely to get the next item wrong. It's not perfect. All right? So we could add a 3rd item and see what happens. Watch what happens to our Cronbach's alpha. So we'll say that our first child will get this one right, 0, 1, 1. This child got all 3 wrong, 1, 1, 0, 0, 0. Now look what's happened to our Cronbach's alpha just by adding a 3rd question. We went from 30-something% to 60-something%. All right, we'll add a 4th question. So 0, 1, 1, 1, 0. This child's got all of our items incorrect so far. 1, 1, 0, 0, 1. Okay, now notice that our Cronbach's alpha has jumped yet again, now to 76%. So you can see by adding questions, and if we were to, additionally, if we were to add subjects or additional children or people taking the test, we would see the Cronbach's alpha, all of the things being equal, continue to go up. Now notice that I didn't enter in the pattern of responses in a random manner. I want to show you just another thing quickly. I'll just do this very quickly. If I go back and I take these same 10 questions, I'm going to clear these contents, and now I do this in a random, more or less a random pattern. 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0. Okay? And now I'm going to do this again, but the opposite. 1, 0, 1, 0, 1, 0. Oops. 0, 1, 0, 1. Look at my Chromebax Alpha. It's doing crazy things because I've got this completely random distribution of correct and incorrect answers. There's no sense of consistency in this data set. I'll do it again. I'll add a third question. Now remember, by the time we got to the third question last time, by doing it in more of a pattern where we had children who were consistently scoring low or consistently scoring high, we saw that Chromebax Alpha grew or gained. All right, so we'll do again the same thing. 0, 1, let's see, 0, 1, 0, whoops, that should be a 1, that one. Oh no, that should be a 0. 0, 1, 1, 0, 1, and 0. Look at what's going on with my Chromebax Alpha. It's not gaining anything. Why? Well, we'll do the fourth question. We'll go back and just remember, compare to, we had 0.7 as a Chromebax Alpha, which is a good number. 0.7 is, that means 70%, reliable, if you will, or 30% of it is error variance. Let's go ahead and we'll add our fourth question. 1, 0, 1, 0, 1, 0, 0, 1, 0, and 1. Look what's going on with our Chromebax Alpha. We're getting this crazy negative number. Why? Because there's absolutely no pattern in our results. So in truth, this wouldn't yield anything in terms of a real reliability coefficient. You wouldn't actually get a negative value like this out of SPSS. But what you would find is that you just wouldn't have a positive correlation in our scores. Now notice our correlation is actually negative. Okay, it's close to -1, which is also a perfect relationship, but in terms of internal consistency, that's not what we would want to see. So internal consistency is highly dependent on the number of questions, and it's highly dependent on the number of people taking the test, but it's also highly dependent on the variability. Now we have a lot of variability here, right? We have a lot of variance in this, but what we don't have is we don't have consistency. And so again, this is what it's measuring, is the consistency with which one subject performs across questions, and also the consistency with which questions are difficult. So in this case, there's no consistency in how the person did, nor is there any consistency in how difficult the question was. So, not surprisingly, our Chromebax Alpha is very poor. You would be very displeased with this as a teacher, getting these results, because we have no sense that children consistently do or don't know an answer, nor do we have any sense that children or answers or questions are consistently more or less difficult. So we've lost both of our basic premises for internal consistency with this little small data set of randomly distributed scores. All right, so let's jump back to our slides. So what's the upshot for you as teachers? When you're using a selected response or performance assessment, the number of different items that you use is absolutely critical. So you could see that with 1 or 2 items, Chromebax Alpha couldn't possibly be good. The second thing is that there's an issue of integrated reliability that is completely dependent upon the rubrics that you're using, the training of your raters, and the clarity and quality of your questions. Now, we actually haven't addressed this issue directly, but this is one of inter-rater reliability. And sometimes we will have an essay, and then we'll grade that essay against a rubric or a performance standard. But what we find is that people do not consistently grade certain performances. So one of the things that is going to be our activity for the reliability piece this week, and it ties directly back to this inter-rater reliability issue, we're actually going to be extending this part of the discussion out. And this is your second discussion topic, and what we're going to be doing is actually creating some performances and a rubric, and we're going to be asking other people to rate those performances. And we're going to talk about the consistency with which people are or are not able to accurately rate your performance based on your criterion that you set forth in your rubric. So be looking for that. That's going to be one of that's going to be the discussion topic and also the second assignment on the topic of reliability for this coming week. So if you have questions or concerns about reliability, you want to be directing those questions toward me or towards the discussion board. This is a simple topic in one sense, but it's fundamental in a second sense in that without a consistent set of results, there's no way that a test can actually reflect what you say it measures.